Wait a second. How many? Did I?
Hit the button. Hello and welcome to the HACKADAY podcast. I'm Elliot Williams.
I'm Dan Maloney.
This is episode 240. We'll be talking about an amazing 3D printer, a look inside the Raspberry Pi 5, and cameras, both film and digital. This week in HACKADAY news, we announced the first round of speakers for SuperCon. SuperCon is coming up the first weekend in November. If you don't have tickets, you should get them now. Actually, I shouldn't even say that. I haven't double checked to see if there are any anymore. Hold up, let me go see if it's sold out yet or not. That would be lousy. No, there are still a very few tickets left. Okay, this is for real. If you want to come, get your tickets now. Head on over. And if you are on the fence, go check out the post where we announced the first round of speakers. This is only half of the speakers we'll have, but there's 15 of them, and all of the talks are going to be fantastic. A couple of people said this in the comments, and I totally feel this way, but it's just so nice to see everybody's faces all put together like this.
Yeah, it's quite a rogues gallery, isn't it?
Yeah, right? It's
Everybody's good looking. What can I say?
It is. It's true. It's a good mix of kind of HACKADAY classics plus a bunch of people who haven't given a presentation on SuperCon stage before. So it's a really good mix.
Yeah, I think so. And looking over the titles, I really like what I see. There's going to be some interesting stuff there. Especially interested in that Deep Space Network stuff from Dave Prucci.
Yeah. He is the man, too. He's been doing all this like really crazy big dish listening stuff. I actually don't want to even get started on it because there are too many here that I want to. Like I can't pick one. I can't start with that here. Anyway, super excited. Get yourself tickets if you're coming. If you're not, then book off the weekend, November, to watch the HACKADAY live stream over on YouTube. We'll be streaming all the talks live, or at least the main stage live, depending on how the logistics works for that. But you will have, 2 full days of talks ahead of you, even if you are only joining us from the internet. And by the time you are listening to this podcast, I think we have opened up tickets for workshops. And I can't see into the future for me, but workshops usually sell out in a few hours. So if you wanted one, I hope you got one. If you're listening to this now and for some reason the past hasn't repeated itself, go see if you can get yourself a workshop ticket if you're interested in one of them.
And since they'll be listening to this on Friday the 13th,
ooh, yeah,
they'll be pushing their luck if they didn't.
True.
So best of luck to you. Watch out for all the usual superstitious stuff.
This is a journey into sound.
What's that sound?
What's that sound?
Well, speaking of superstition, would you like to do What's That Sound?
Oh, is that a little foreshadowing for me?
That's always good luck. What's that sound?
All right.
Always good
all
luck.
Right. I'm embarrassed. I know.
Oh, no.
I know I should know this. It sounds like the final victory song of some game, and I'm not going to be able to tell you exactly which game. I don't know, maybe or something like that.
That might be right.
That might be right.
that might be 100% right.
Oh, okay. All right. Well, yeah. I don't know if I've ever actually gotten to that screen on my own power.
It's actually just the screen at the end of every level.
Oh, okay. All right. So there's not one big final. Okay.
Oh, there is a big final one. I was going to pick that, and then I picked that by mistake, actually. I downloaded that by mistake, and I'm like, I've never heard this song before. So,
well, there you go.
That's probably telling. But this one I know. This is the one I was going for. This is the one I got.
All right. Well, I guess I got lucky.
Congratulations. See, Friday the 13th is just superstition.
Yeah, but it's not Friday the 13th for us. It's for them.
Oh yeah. Maybe you only got it because it's Wednesday the 11th. Oh, fair enough.
Exactly.
Well, if you are out there and it's Friday the 13th and nonetheless you know what this sound is, head on over to hackaday.com/podcast. Fill out the form, write down your name. If you get it right, good news is it's going to be yet another week before we draw for a winner. So you will no longer be on the unlucky 13th, but rather the horribly lucky 20th. And someone will get a Hackaday podcast t-shirt. Our first hack this week, well, it's kind of co-news, is from Raspberry Pi. Raspberry Pi reveals a little about their RP1 peripheral. This is a video coming from the Raspberries, and it has CEO Ibn Upton interviewing CTO James Adams and Liam Fraser, who was on the ASIC team that developed this new RP1 chip. And in case you missed the big Raspberry Pi 5 reveal last week, they went from a monolithic system on a chip design where a single Broadcom chip did everything to this current state where there's kind of the CPU and the GPU on the Broadcom silicon and then their own chip. This is the RP1 doing kind of all the traditional Southbridge stuff, which here means like camera interfacing and USB and all the GPIOs and what else? I think that's it. HDMI video, audio in and out, all that sort of stuff. All the peripherals basically are handled on the RP1. And this split makes a lot of business sense because the GPU/CPU is on one of these silicon processes that gets ever smaller and smaller and becomes more efficient and runs faster and all of that. But at those super tiny scales, it's A, more expensive to make the peripheral interfacing, but B, some of those things actually benefit from having bigger silicon transistors. So the RP1 is made on an older, I think it's 40 nanometer process. Don't hold me to that, but it's the same process as the RP2040 their microcontroller is on. Ooh, story about that in a sec. And then the processor system on a chip stuff they just buy from Broadcom, and that's 16, I think it's 16 nanometers at this point. The point is, this means that the RP1 and the peripherals are made up of bigger transistors. They're actually, I actually asked even if they were 5-volt tolerant, and he said, whatever you do, don't say 5-volt tolerant. They won't necessarily fry if you put 5 volts into them. He actually got into a bunch of trouble with his engineering team for some Hackaday comments, ironically, about the Pi Pico, saying, oh yeah, they're totally 5-volt tolerant. When in engineering speak, 5-volt tolerant means they've been tested out to 5.5 volts. And so there's 5 volts is fine, plus a little bit of a safety margin. And nobody knows what the safety margin is on either the RP2040 or this new kind of Southbridge chip on the Raspberry Pi 5s. So don't say 5-volt tolerant, but you can probably get away with running the pins at 5 volts. On the other hand, if it burns out at 5.3 volts, you can't come complaining to me or to the Raspberry Pis.
So they've got zero tolerance for 5-volt tolerance talk.
Ooh, sick. The really cool thing about this video is it goes really into depth about all of their work on this project to make this little Southbridge chip completely in-house. And this has cost them, whatever, they're saying $25 million in development costs. They've been at it since they started the RP1 project in 2016. So this was back when the Raspberry Pi 2s were the current ones on the market.
Wow.
So they've been working on this for a long time. Those of you with eagle eyes will have noticed on the Pi Zero W, the chip there was actually some Raspberry hardware, and it was called the RP3. Ironically, that came out before their microcontroller, which is called the RP2040, and ironically, that came out before this chip, which is called the RP1. And is this 1, 2, 3? Yes, it is. It's no coincidence, but the point is this chip was kind of much more complicated than either of the other two. And what happened is they took their learnings from working on this Southbridge chip, and that kind of influenced the design of the microcontroller. That's where the PIOs, the programmable input-output, high-speed serial stuff comes from. It comes from what they were developing for this RP1 Southbridge chip. And the building out of all the tool chains to build this chip was what gave them the capabilities to make what would become the RP3. So there's actually a really neat silicon development story here, and a lot of that's covered in this video. Some of this may be new surprises. Some of this is in the video.
All right, my first pick is use your old SLR as a digital camera. And no surprise, this one comes from Jenny List, our resident camera geek and analog photography aficionado. Like me, I started in photography like in high school, and it was, of course, film photography way back then in the dark ages. In college, I was photo editor of the yearbook, and the best part about that was getting free film, free processing, and free cameras. We'd get the latest, greatest, whatever. And my dream camera was the Canon F1. I knew everything about it. Loved the fact that everything on the camera was controlled by a physical control of some sort, a button or a knob or whatever. The idea that you could take that same physical experience of photography and get the benefits of digital to go along with it would be really cool. That's what this tries to achieve. This is from I'm Back Film, kind of a clever name. And basically what it looks like to me is a cartridge that looks very much like a film cartridge, a 35 millimeter film cartridge with an attached sensor. The cartridge positions the sensor in the focal plane of the camera and allows you to, instead of put your image onto a piece of film, it puts it onto a sensor. The idea is sound. I'm not entirely convinced about the details myself, and I think you probably have some skepticism about that as well. But I do like the idea here. The sensor is supposed to be 20 megapixels, micro 4/3 sensor format. So you're going to end up on a 35 millimeter camera. You're going to end up with a cropped image. That may or may not work for you. It's up to you. Could be an artistic effect, maybe, if you want to look at it that way. There's some other problems that may come up, like the distance between the roll of film and the focal plane isn't standardized in any way, as Jenny points out. So how do you make adjustment for this camera will, be a few millimeters longer than another camera will be? There's maybe got to be some sort of adjustability between the cartridge and the sensor. There's also the problem of how do you really interface with the camera controls? That seems to be a problem. There's a ribbon cable that connects to something. We're not quite sure what, looking at this sort of press release kind of thing, but it's a promising idea.
Yeah, I went looking for more details too. I went over to their Kickstarter and tried to find some. I was looking at their website and tried to find some, and I just don't see what I want to see, which is, how does the digital processing back know when the button's pressed? It does have that little, there's like a ribbon connector, but how are you going to connect that to the shutter button on your camera? Moreover, how are you going to connect it so that when you half press the button, it does the exposure and holds it? And how are you going to adjust all that? Maybe it has Bluetooth in it. Maybe you can remote control all this from a cell phone. I don't know. Digital sensors have an ISO rating like film used to, but they don't do it the same way film did. Film had different chemistries that would, say how much it exposes per unit of light coming in. And the sensor really just reads the data in, and then it multiplies it up if you're in lower light, right? And it's literally just, it's an ADC on the chip, and then it's like multiplying digital numbers at that point. So it's not the ISOs are kind of irrelevant, but it's also something that's nice to have control of if you're shooting anything other than RAW formats. So this is something that I'd like to have a control on the camera for. The shutter is weird. There's just a whole bunch of things that I kind of wish I understood how they were going to work around.
And now I just want to go drag my old camera bag out and see how my old cameras are doing. I haven't visited them in a while.
Aw.
Oh, yeah. Maybe run roll of film through them too, if I can find some place to get it processed.
All right, my next hack is a 3D printer design that you have not seen before. I think I can guarantee this. Marionette 3D printer replaces linear rails with string. And this is a new 3D printer design by Dietzakat, and he's gone through it in a few different YouTube videos. You should definitely give them a look. The game here is that the entire linear motion system is done with cables and winches instead of with linear slides or with linear rails. And it's really interesting. The XY stage is crazy. It's a lot like one of those polar plotters, if you think about them. The printhead slides along on the underside of a flat piece of glass, and it's controlled by two winches that are motor driven, but it's held up from the two other corners by two other strings, where if you were doing one of these polar plotters, of course, you'd have gravity holding those two lines taut. Here, you need these other two lines to hold the head taut, but they need to give and pull tight as the driven two lines get pulled tight and loosen. And that whole thing is incredibly nonlinear. And the solution here, and this is why it's called marionette, is a four-armed linkage that goes on the top of the glass plate that this thing slides along and pulls those strings tight in exactly the right way to hold tension everywhere in the system. I have never seen any motion system like this before. It is really insane. I'm not even 100% sure I understand it. The X and Y motors pull on the strings that directly move the head, but then they also pull on other strings that move a center pin on this four-armed wiggly thing around, and that then tightens the two other wires that go to the head. Bonkers. And if that weren't enough, the Z-axis is also completely wire driven, and it has 6 wires, all of which meet together in the middle and are all pulled the same way. The trick there, of course, is that you've got this like hypotenuse of a triangle problem. When the bed goes up, it's like it's like one leg of a triangle getting shorter, and the cables are the hypotenuses of it. DZCat has designed a special nonlinear winch pulley here that decreases its radius with the square of the Z height and stuff, so that the Z height changes linearly, even though you have to be pulling more string in to move it. It is absolutely insane. He's also got a separate video on that one just running by itself that you absolutely should go check out. What else is crazy about this printer? Everything. It has to have a right angle print head because the print head is held tight up against this piece of glass. The glass is really clever because a plane of glass is a very cheap and easy way to get a very flat reference surface. So the print head holds level extraordinarily well because it's pulled up against the plane of glass as it moves. He seems to get really decent movement speeds and accelerations with this. It has all sorts of crazy cable-driven, interesting details, including tightening up the cables with guitar tuners.
I thought that's what those were.
Yeah, isn't that awesome?
Yeah.
I can't even imagine how you would level this thing. And somebody asked that in the comments, and DZCat comes in and says, "Oh, I'll make a video about that soon." It's actually not as bad as you think. So we'll see upcoming videos on the 90-degree head on leveling this thing. It's no exaggeration. It's a 3D printer design that I have absolutely never seen before. And this like wire tautening mechanism is just absolutely marvelous to see in motion.
I look at this and there just doesn't seem to be any way to control vibration. The slightest little tap on the table seems like it would set everything into kind of a resonant thing, and you would just get a head going up and down, up and down, up and down. But apparently you don't, because the print quality seems to be pretty good compared to what I would think would come out of a machine where the print head just continually went through the Z-axis in this uncontrollable vibration. So I don't really see how he controls it.
My guess is that if the cables are tight enough, right, that pushes the resonant frequency way high. And if you get lucky, it's out of the realm you're worried about with the printer head moving.
Yeah. Okay.
But I do see what you mean. Yeah, I don't know what he's using for cables there. I presume he's using, there's a bunch of brands of fishing line that don't stretch at all, or he could be using like Kevlar kite line or something. I don't know. My guess is he has to be using something that doesn't stretch at all there.
It almost looks like a cable that was used in some robots I worked on when I first started in laboratory automation. Very, very, very fine stainless steel wire with a plastic coating of some sort. Very flexible, but super, super strong, and no stretch to them once they were kind of pre-stretched. So maybe that's what it looks like. The diameter looks a little low for that, but the color's right anyways, the cover. I'd be curious to see what he used and how he deals with things like stretching and strength.
I secretly love cable robots and cable driven anything, and because it moves a lot of power through very small things. Like it lets you move the motors way off board, and actually that's what he's doing here. There are kind of no motors have to be moved around in this 3D printer. They're
Right.
all activating these cables. So the entire moving mass is just the hot end. It's fed by a Bowden tube, so like nothing heavy has to move around, which will help him get faster speeds as he develops this more. And so that's kind of the coolest thing. We have seen things like this before on the super giant scale. Of course, there's the hang printer, which was designed to suspend off of cables pulled down by gravity and basically print room-sized things. On a smaller scale, a really neat printer made by Darren Schwenke, the Arcus 3D, is a cable pulley printer, and there he has a spring-loaded, what he calls it, his like artificial gravity enhancer or something. It's a spring-loaded line that pushes down on the print head. So you pull up from 3 different cables to locate it, kind of like a Delta printer would, but then you push down on it with the spring-loaded thing that makes it sit in one place instead of sliding around as you move it. That's a really cool design too. This printer somehow figures out the math and the mechanics to make the other 2 cables pull exactly right so that it's always taut. If you want to head down this cable design path yourself, I have to recommend Joshua Vasquez's awesome write-up of his work on CableBot's cable mechanism maths designing against the capstan equation. You should really check that out if you want to kind of replicate some of this work or something similar on your own.
Because of course there's a capstan equation.
Yeah, well.
There's an everything equation. There's a catenary equation. There's a this equation. There's a that equation. I love it.
I'll tell you what I learned from that is that the friction, the amount of force you can hold with the cable depends on the number of turns as much as it does on the like friction of the thing against the capstan. So you can, double the friction of your capstan material. That buys you only as much as going an extra loop around. And which one's easier? So you just do 3 or 4 loops and you've got kind of infinite holding strength on that. Learned that from reading Joshua's article.
And in Joshua's article, there's a link to a McMaster car item of the cable I was talking about.
Oh, right. See?
So cool. So it does exist. I'm not I'm not making it up. Okay, next up for me is creating an automated hydrogen generator at home. This one is by Hyperspace Pirate, and we've been following some of his videos along for a while now. I don't exactly remember what the reasons are, but he needs hydrogen for liquid hydrogen. He wants to make liquid hydrogen, which I fully support because liquid hydrogen sounds like really cool stuff to play with for a little while anyways. This experiment or this process is basically taking the little experiment or demonstration that you would get in high school or grade school chemistry class where they would demonstrate electrolysis, and there's sort of the 2 inverted test tubes in a bit of water with a little bit of electrolyte added to it. They'd stick some electrodes up the tubes, and one tube gets the hydrogen and one tube gets the oxygen, and you would take those tubes out and you'd be able to prove that the hydrogen was in one tube because you'd put a splint in it. It would pop, you'd get the explosion. In the other tube, the splint would just sort of flare up, and that's the oxygen. That works great for generating hydrogen and oxygen, but it's a little hard to flip test tubes around and manipulate things like that. That whole process can be automated, and that's exactly what Hyperspace Pirate did here. He basically took inspiration from watching his dog drink out of one of those automated waterers. So he's lapping up the water, and then and the water level goes low enough to create a leak of air, and the air bloop, 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 goes up into the jug. And then when there's a vacuum up there, then that's it. It keeps the water from flowing out. He kind of recreates that whole mechanism, but adds in the electrolysis mechanism at the base of this. So basically what this is a bell jar in a pool of water, which has a little sodium hydroxide added as an electrolyte. It's got 2 electrodes, but they're in the form, each electrode's in the form of a ring. The cathode is inside of the bell jar. The anode is outside of the bell jar. So the anode is where, let me see if I get this right. The anode is where the oxygen comes off of, and the cathode is where the hydrogen comes off of. So by sort of physically segregating them with the wall of the bell jar underneath the water, he's able to make sure that the hydrogen is the only thing that's going to go into the bell jar. Oxygen kind of just vents harmlessly to the atmosphere. So once the bell jar is sort of evacuated of air, which can be taken care of through a pump and a line that goes up to the very top, the apex of the bell jar, evacuate that whole space, turn on the juice, you get hydrogen bubbling up inside the jar, oxygen bubbling up outside the jar, and eventually the hydrogen pushes the water level down to the point where it's going to break the seal. And at that point, he can that whole bell jar is full of hydrogen. He can take that, pump it off, and put it into a storage vessel of some sort. That's straightforward enough, and he demonstrates doing that manually right up at the front of the video, and it all works fine. But it's a process that's perfect for automation. He automates it by, first of all, looking for the water level of the part of the reservoir that's outside of the bell jar. So when that's forced higher because the hydrogen has collected in the bell jar, closes some contacts that can turn on the pump that pumps off the hydrogen and then kind of starts the cycle all over again. Basically what he wants to do here is generate a lot of hydrogen, and not just store it in party balloons and then make the party balloons go pop, or just send them up into the atmosphere or anything like that. He wants to actually get a tank of hydrogen. It solves the hydrogen embrittlement problem, which is, I guess, pretty well-known problem of storing hydrogen in steel tanks, is that because of the fact that hydrogen is so tiny, it works itself into the crystal matrix of the steel and renders it brittle, and then you've got a tank full of high-pressure gas that's not structurally sound, and we don't think that's a good idea, and he doesn't think that's a good idea either. So he went with an aluminum tank, and basically at this point now, he's got the ability to generate as much hydrogen as he wants, store it safely, quote marks around safely, as safely as any tank of hydrogen can be stored. Do it at will, and it's a walk-away system because he's got it completely automated. Just thought this was really clever, and really looking forward to seeing what he does with the liquid hydrogen. I know he's done a lot of cryogenic stuff before, so I think it was all in service of this goal of making liquid hydrogen at some point. It's kind of neat. You should check it out.
The automation part of this was the absolute highlight for me. I've done some of the kind of, small scale hydrolysis stuff just for fun, just to make balloons that go bang. And because I never could get enough of it to do anything useful with it. And I think the automation part here is exactly what makes the difference there between having enough of it to be fun and enough to be useful. So I wish him luck. It looks like a really sweet setup.
It just occurs to me that the automation end of this reminds me a bit of the oxygen concentrators that we saw a lot during the acute phase of COVID, and people were making
absolutely
all those oxygen concentrators, and they basically just run themselves. I mean, there's plenty of automation in there, you have sensors and pressure switches and things like that, but basically they just run themselves and just collect a whole bunch of oxygen, and you can actually get a therapeutically useful flow of oxygen from those things. Put a link to one of them in the show notes so you can check it out.
And bringing up the rear on hacks from me, from Jim Lill, a video, just what is tone in a microphone. He lives in Nashville, has access to both his home studio and some professional studios, and long story short, takes a whole bunch of microphones, builds a microphone comparison rig, and runs them all through it to see what you can see. It's a really fun video. It shows the differences in kind of the equalization profile, in the like tone contours of a whole bunch of different microphones. And he has a particular goal in mind, which is to replicate the setup of one studio and how they mic'd up some songs that he really likes. And so he's got a whole bunch of particular kind of sound palettes from the microphones in mind, which include, you know, the kind of dead microphones they use for miking up bass drums, and the kind of shiny, sparkly microphones they use for overheads for drum sets, and you know, the quiet, vocal, pleasing ones they use for singers, and you know, all the above, right? If you haven't played around in recording studios, you may not know, but there is a microphone for every task and a task for every microphone. And that's part of what is fun about this video, is you can hear the differences between them. Now, his testing rig is just a speaker and a frame that he can use to align the microphone so that they're always in the same place and the same distance from the speaker. He plays a known recording of known volume through this setup and into the microphone. He also runs a frequency sweep through these, so he gets kind of this normal frequency response curve out of it. He doesn't have a professional flat reference mic, so he uses the Shure SM57, which is kind of a normal dynamic microphone. It's like, I don't know whether the 57 or the 58 is. Like the 58 is that one with the silver basket on the top that you always see in live shows, and the 57 is the one without that silver basket. So it's a little bit more sensitive to wind noise, but it's used a lot more in studios and stuff like that. But they're basically the same mic. You've heard this microphone before, and that's why he uses it as a baseline. And I think that's kind of fun too. Comparing, you know, multi-$1,000 microphones against this $100 microphone is an interesting choice. I think some people came away from this video saying, you know, this expensive microphone is as good as this not expensive microphone, or vice versa, or whatever. And I think his point is much more nuanced here, which is that he wants to see what all of these different microphones sound like so that he can get a microphone with kind of the right frequency response for the right job. And I think that's actually kind of legit. If I get to be picky about this whole thing, I think his testing on A, recording, and B, fairly close up to it, means that he's kind of leaning into the microphone's proximity effect pretty hard. And that is, when you get closer to a microphone, it picks up a lot more of the bass than when you're further away. And different microphones really have different levels of proximity effect. And that's something he's not measuring here. He actually does play super loud into them to see if he can distort them, and discovers, no surprise, the dynamic microphones are really hard to distort, and that's why rock singers will like scream into them. Yeah, and then the fancy capacitor microphones that are good at recording delicate light sounds are easy to distort, and vice versa. So, you know, no surprise there. Some of the stuff, once you know it, you can just kind of fix it all with EQ in the studio later. And I don't know. I guess part of the reason you want to have a bunch of microphones in the studio is so that you don't have to be like micro EQing all the different tracks to match up with each other. And I guess there is the question of whether it'll record all the detail. And he kind of glosses over that a little bit by playing his sound sample in there loud enough, and by normalizing everything to the same volume after the fact. What? Is this the be-all, end-all of microphone comparisons? No. But is this the best video I've seen that kind of lays out what a whole range of microphones, from cheap and broken to, you know, these expensive, you know, ridiculously expensive microphones sound like? And the answer is yes. And so that's actually a really cool side effect of it, is if you don't know that different microphones sound different from each other, you'll get to hear them all in this video.
Yeah, and I think that was the important part for me. I kind of went into the video thinking, he's going to do some audiophile nonsense that, you know, can you hear the difference between this and this? And it's like, no, you can't. No, nobody can. No, you know, the difference between the way speakers sound with oxygen-free cables or gold-plated conductor, you know, that kind of stuff. I thought it was going to be that kind of nonsense. And it wasn't. The tests were very real world, and I think also was really important about the way he organized or edited the tests, I guess would be the best way to put it. each music clip was very, very short, third of a second, maybe a half a second. So you'd get a full range of sound in the clip that he played, and then he'd play the exact same clip right after that. So you'd hear kind of thing, and you'd go through, and you could very clearly, when he did it that quickly, that close together, you could very clearly hear the difference. That one is much brighter sounding. That one was tinnier. Whatever the difference happened to be, you could really pick up the difference quite easily as a tin-eared amateur like I would be. It made it a lot more approachable, practical sort of, can you hear that difference? Well, yeah, for sure I could hear that difference.
And don't be fooled by the video thumbnail here. He's got a microphone that he has built on top of a pop can with a window screen as the shield on it. But what he's using in there is a really nice $350 capsule. And, whatever cheap but plausible amplification he can. And I guess his point here is that if you buy a good mic capsule, it's going to sound like a good mic. And he compares this against the Neumann, and it comes out in his test sounding exactly the same. And, to my ears anyway, exactly the same. And I'm not 100% surprised there. I mean, he bought a $350 cartridge and didn't screw up the rest of it. Like, that's going to be a pretty good microphone. So, good on him, but putting it on the pop can is good theater. but he's actually done all of the work correctly to make a really good sounding microphone here. And maybe that's an interesting take home, is that if you get a microphone capsule that has the sound you want, and you do kind of minimal/reasonable electronics on it, you're going to get a microphone that sounds exactly like you want. And, how much money you want to spend on that is probably up to you. Is a $10,000 microphone better than a $500 microphone if you do everything right? The answer is probably no. But is a $500 microphone better than a $100 microphone? If you're looking for that particular sound, then the answer is, of course.
Okay, last up for me, polish up your product with graphic overlays. There's a big difference between project and product, and we've talked about that here on the podcast before, and we've done plenty of articles on that. And I know in a lot of cases, I tend to be more willing to write about the more polished and finished looking projects that have kind of taken the extra step. I know Elliot likes to do the wires flying everywhere projects. And I like those too.
If the front panel isn't written with a Sharpie, I don't want to see it.
Well, yeah, and then there's that next step, taking it from Sharpie level to a finished product. And no, I agree with that. I love the ad hoc projects. I love the give me a Dymo label with an embossed label for that's on a hammer tone gray case. I love that kind of stuff too. But when you're going to go to make a product that's going to go out into the market, you're probably looking at a different level of fit and finish that will convince people to part with their money for your product, whatever it happens to be. In this case, we're talking about graphic overlays and acrylic panels that can be used to dress up a product. This is from Kevin Hunkler, who has been working on a thing called Knucklebone, which is basically an automatic dice roller for RPG games or board games or whatever you need to roll the dice for. This will roll virtual dice with a random number generator and all kinds of really cool stuff. So it's a cool idea, and it needs to go into a cool package, and it needs to look like a finished product. And he certainly manages to accomplish that. However, it wasn't terribly easy to find the way to do this. And he kind of, through this page, takes us on the journey of what exactly that was like and what was involved in making these labels and overlays. As Donald Papp, who wrote the article, points out, it's not a lot different from the PCB process, the whole process of designing and ordering a PCB. You've got to basically come up with design files, description of, what defines each layer. Is this a transparent layer where LEDs are going to shine through, or where in this case an e-ink display is going to shine through? Are there going to be holes here and there for things that are going to stick through the panel, like switches and indicators? What the colors are going to be, how you define that stuff? All of that is taken care of, or is at least addressed in this article as sort of a, hey, I learned this the hard way. Here's what you need to know if you're going to do this process. Unsurprisingly, there are plenty of places that specialize in making these kind of overlays, these graphical overlays that will either stick to a front panel with adhesive, or will be an acrylic overlay that'll fit in some sort of bezel. It's not really the kind of project that you can do yourself. As far as I know, it's not like you could take a vinyl cutter or a laser engraver or something like that and put some material on the bed of that and then create one of these on your own. I'll take that back. You probably could do that, but is that really the best use of your time when there are places out there that actually do this for a living? It's kind of like the same thing, again, going back to PCBs, kind of the same problem. You can do it at home. You know how to etch, you know how to lay it out and all that stuff, but is it worth it? Is it worth your time? And is it something that scales? And for a commercial product, like he's got I think it was a Kickstarter or something like that to sell this knucklebone product, probably doesn't make any sense when you can buy them for 50 cents each, and when you're buying in quantities of 500. It makes a whole lot more sense to just ship that out to somebody and have it shipped back to you ready to apply to an existing enclosure. Kind of a neat look at an area of production or manufacturing that we don't really think about a lot, but it certainly adds that last 2 or 3% to a project or to a product that makes it finished looking and very professional. And I appreciate the been there, done that look at this whole process.
Like you said, if you're making a one-off or whatever, it's probably not for you. He breaks down the costs here, and he can get 5 of these front panels made for $80, but he can get 500 of them made for $250. So the price drops from being $16 each to being 50 cents each when you're doing it in quantity. And that's that's the difference here, right? If you're going to sell 500 of these, it's a no-brainer that you want to get these manufactured by someone else, because even if you could figure out a system to do the laser marking of acrylic on your own laser cutter, it just wouldn't be worth it for you in time. It wouldn't be worth it for you in your time, in the laser time. Like even the electricity you wouldn't even pay for. So just, get it designed and get it done. And I think that's exactly what he's kind of proposing here. And it's a great look at how you do that.
Yeah, it sort of put me in mind of a project that I wrote up recently, a programmable resistor that looks unbelievable. You look at this project, I'll include a link. You look at this project and you think, well, that's something that HP made in, 1995 or something like that. And he just got it refurbished. Like, no, this is a project that was just built from scratch. And the fit and finish on this is just incredible. The neat thing about it is the front panel is PCB. He actually did send this off to like JLC PCB or something like that, and just had them make this just for the silk screen, just for the structural properties of FR4 and his ability to put holes in it where he wanted to, and just made the front panels out of PCB. There's nothing circuitry about this. It's just a panel, but it was a very clever use of an existing thing that we all have access to make a really snazzy looking front panel and have somebody else do it and make sure that, to CNC standards, the holes are where they're supposed to be, and they're square where they're supposed to be square, and round where they're supposed to be round. And I thought that was a really cool way to kind of leverage the tools that are out there.
My first quick hack this week is a video from StyroPyro wiring up 100 car batteries so you don't have to. This is in typical form, a little bit irresponsible, but also tremendously neat engineering. He is putting these batteries, at first all 100 of them in parallel, just to see how many amps he can draw when he shorts them all together through something. It ends up being the connection between these two gigantic copper plates, and whatever he's trying to fry ends up having too much resistance, so he does them 5 in series and 20 in parallel. So he's got at least 60 volts. Ends up drawing like 50,000 amps through things that include a literal crowbar and melting them. It's a fun video. But the best is in the last few minutes when he talks about this crazy switch he built out of a log splitter, all the problems he had with the cabling, and just handling this level of current that you're not used to unless you are a lightning strike or something. Next up, David from Usagi Electric is repairing an old computer and learning about ferroresonant transformers while fixing a 1970s power supply. I didn't know what a ferroresonant transformer was, but it's a constant voltage transformer, and that sounds vaguely familiar. These work by using a shunt and a second coil that has a capacitor on it to keep one side of a transformer always saturated so that the voltage doesn't fluctuate, so that it puts out a nice stable 5-volt power supply while not affecting the other side that's plugged into the wall. This is a really neat old trick, except looking into it a little bit, I see why it's old. The secondary runs at about 45 to 85 degrees C hotter than it would otherwise because it's continually saturated. This is why we have switching power supplies these days, people.
Right.
Next up, Microwave 1, antennas can be a total mystery. This is a long video by Ham about all the crazy antennas he's seen in his life that nonetheless worked. And this is consistent with my experience. A dipole has never failed me, but every once in a while there's a strange antenna that works in this one situation but not in another, and there's too much physics going on. You don't know why. That's the story here. And last up, dumping spacecraft in the middle of nowhere is a write-up by the BBC, and I just wanted to say oceanic pole of inaccessibility, which which, if you don't know, is the point in the ocean that's furthest away from land in any direction, where they end up dropping satellites when they fall back down to Earth. But I just like saying oceanic pole of inaccessibility.
Point Nemo, too, right? Don't they also call it Point Nemo?
Pole of inaccessibility. I mean, that's a very landist perspective. It's not inaccessible at all for dolphins. What are they on about? Dolphin just swims right over.
Okay, my quick hacks this week start with Spuds Lend a Hand in the Dark Room by C.M. Kelsall, who took a bunch of potatoes and made film developer out of it. Now, this confuses me because I guess I'm not familiar enough with the chemistry of actual film developer. I probably need to brush up on that, but apparently there's phenols in the potatoes somewhere, maybe in the skins, which are actually acting as the film developer. Next up, an SMD capacitor guide. Honestly, SMD capacitors sort of always confuse me. They always seem to be not black boxes, little gray boxes. They almost always seem to lack any markings whatsoever. This guide, a longish video, goes into all the different kinds of SMD capacitors, multi-layer ceramic capacitors, the tantalum capacitors, and even the little cans, the electrolytic cans that are in SMD mounts. Tells you how to figure out what the polarity is. I find it kind of confusing that some capacitors have the anode marked off and some have the cathode marked off. I think that's kind of a little suspicious when you look at them. But also the what the markings are as far as voltage rating, capacitance, all that stuff is kind of handled in this video. And last, implementing Commodore's IEC bus protocol on a KIM-1 single board computer. This is from the Commodore History Channel, and I just sort of picked it up because for some reason I'm getting a lot of KIM-1 love lately in my feeds, and I think we're seeing a fair amount of KIM-1 related retro computer projects on HACKADAY too. Basically, what this one is taking the venerable Commodore 1541 disk drive and figuring out how to plug it into the IEC bus on the side of the KIM-1 single board computer. It's a good introduction to the interface and also the similarities between the KIM-1 and the VIC-20 and later the Commodore 64 are hard to deny when you see the layout of the boards and the schematics.
That brings us to our Can't Miss articles. These are long-form pieces written by our fantastic HACKADAY writing staff. And this week I wanted to pick Jenny's Daily Drivers, Serenity OS, and in particular, Ladybird. This is another installment in Jenny's Daily Drivers series where she tests out odd operating systems and sees if she can get anything done with them. This one's a little bit of an exception because she is mostly interested in the browser component of Serenity OS. And the reason for that is because it is probably one of the only alternative browsers available these days. Chrome, Safari, Edge are all running WebKit. I think the only one that isn't is Firefox. This is, well, an even alternative browser than Firefox on Serenity OS. She fired up the operating system too, though, which I think is interesting. The little bit of history on Serenity, it is a kind of labor of love by Andreas Kling. And the particular story is that he used to work for Apple. He was a WebKit developer, so he used to work on their browser, got himself into a really horrible drug addiction, and as part of his rehab, decided that he was going to write a complete operating system from scratch while keeping clean. And he started on Serenity OS. And it really shows it's a very kind of idiosyncratic / labor of love / what it looks like a blend of old Windows user interfaces, but it runs on a custom Unix core. It's not a Linux version. It's an own OS. And actually just last year or the year before, they went from a 32-bit OS to a 64-bit OS. It's a monolithic kernel, so if you want extra drivers, you have to compile it in. But that's okay because basically everyone using it is pretty hardcore and or developing on it. It's really interesting, and it's kind of, I don't know, he describes it as being, the marriage between the aesthetics of late 1990s productivity software and the user accessibilities of the late 2000s Unix. It's a system by us for us, he says. And I think that covers the spirit of Serenity OS really well. And if that sort of thing is interesting to you, you should really check it out. Jenny got it running in QEMU. I think last year somebody finally got it running on bare metal hardware. So the project has come a long, long way and attracted a large group of developers since its early days when it was a one-man show. But the real star of the show then is the Ladybird browser. And this is a browser that's written by, completely open source by a small number of people, brand new, kind of clean room-esque. I mean, it's written by a person who used to work on WebKit, the dominant browser engine. So he knows what he's doing, but it's also community written. And so it's being developed by a whole bunch of other people at the same time. Jenny fires it up. It struggles on some web pages, but doesn't on others. And it seems to be in this kind of not quite ready for prime time zone. But it's so amazing that you could do this at all that she comes away fairly impressed by how everything works. And given that it's running inside QEMU on her Linux system, the whole operating system and browser environment, she's actually pretty happy with it from that perspective. The OS is stable and usable and everything that it has works. I mean, there isn't a package manager with it, and I don't know if she gets into this here, but you're kind of expected to be able to go fetch the software you want and compile it if you need to, and that's not everyone's cup of tea in an operating system for sure. But if that is, and you like this kind of minimalist style and the like just get stuff done aesthetic that they bring to it, plus the, I don't know, kind of quirky, idiosyncratic feel to an operating system that's a labor of love by a team of like 20 people, then you at least want to give it a look.
I have to admit, I didn't really realize that WebKit was lying at the heart of pretty much every browser now. And I guess to me that sort of explains. I'm running Mozilla or Firefox, and I guess that explains to me why I frequently see one of these condescending warnings when I click onto a website. Well, you should really be using a modern browser. Like, give me a break. It's brand new. I just updated it, and that's, I guess, a reflection of the fact that it's expecting to see WebKit under the hood, and when it doesn't see it, it says, well, forget it. I'm not going to support that. And that's too bad. I don't know that Ladybird is a solution to that at all. And what would it do if it saw Ladybird under the hood when what kind of warning would it put up for that?
Right.
It probably wouldn't even know what to say. So, I don't think Ladybird is necessarily a solution, but it's nice to see somebody doing something that's not controlled by Google or Apple. And I think Jenny even points that out. Like I said, I don't know if that's a solution to anything, but it at least somebody is doing something different. Kind of the whole thing gives me a more of a Wild West sort of feeling from 3 decades ago or so, when everybody had their own browser. Everybody had, different, well, I guess even back then, everybody was pretty much using either Apple or Mac, but it was the pre-Google days, and everything was probably a whole lot nicer. Even though you couldn't get as much work done and everything was a lot slower, it was kind of nice to see this as sort of a trip down that old feeling. Nostalgia road, I guess.
If you haven't been browsing long enough, in the early days, there were only a few browsers, and then I guess Microsoft's Internet Explorer captured the market and kind of pushed their extensions and ways of viewing the web onto things. And that was kind of a dark time in the early days. The fight between Firefox doing basically standards compliant stuff and Internet Explorer kind of doing their own crap. Those were horrible web compatibility days. And then we kind of got through that. And then along came WebKit and Chrome. And now we're getting back into that zone again. And I've had exactly the same experience you have, where, this doesn't work in Firefox. You have to go fire up Chrome to make it work. And, running back into that kind of browser monoculture really does worry me a little bit. And, I don't think it's good for the internet as kind of an open culture to be there. I guess I kind of also agree with you that I don't know if one small fringe browser is going to make all that much of a difference, but still it's really awesome to see them out there doing it, from that perspective, from a kind of fighting the monoculture perspective. I kind of wish that corporations didn't control the internet.
You think? My pick this week is You've Got Mail. It All Depends on Zip Code by Kristina Panos. I've been looking for an excuse to feature one of Kristina's You've Got Mail series articles for a while. I've got a soft spot for actual mail. I mean, a lot of what I get is just trash, obviously. Some of it just goes right into the recycling bin before it never even makes it into the house from the mailbox. But there is something about an actual letter from someone that's not looking for money from you, but being able to actually put a piece of paper into the mail and have it directed someplace else on a gigantic country that's the size of a continent, or even beyond, anywhere in the world, and have that actual physical object transported there. If it's 50 cents, it's a bargain at twice the price for someone to do all the work for you of transporting that thing to someone else. So the whole mail system, the whole postal system is really fascinating to me. The way it has scaled over the years from, Ben Franklin's days when he was Postmaster General to now when things can get directed automatically and robots do a lot of the work, is a kind of a fascinating engineering story. Anyways, this installment of her series is all about the zip code, which, for those of you who don't live in the United States, is our version of postal zone encoding. It's been around since the 1960s. Its predecessors have been around since, I guess the 1940s or so, when the scale of mail through the system just got to be too much for simple handwritten addresses to ensure that mail would get to the right places without some sort of help with numbers instead of just addresses. The idea of the zip code in the United States, like I said, came around in the 1960s. I can actually remember when zip codes were sort of a new thing. You didn't see them on every envelope, and I do remember the early marketing efforts that they went through Mr. Zip and all of that stuff. Kristina's got a great video at the bottom of this article that is absolutely hilarious to watch the Swingin' Six sing about the many virtues of zip codes. So you got to check that out. The details of ZIP, which is actually an acronym or an initialism, I guess, Zone Improvement Plan. It just so happens to have a connotation of zippiness, fast, speedy service, that kind of thing. The basic plan is dividing the entire country into 10 different zones, because it's zero enumerated, folks. Starting at zone 0 in the northeast corner of the country and going all the way to zone 9 in the West Coast and Alaska and Hawaii. And then dividing each one of the 5 digits representing a different geographic region of the country, so that you get finer and finer detail as you go further and further out with the numbers. So the 5-digit codes came around in 1963 or so. They were optional at the time and quickly became a way of making sure that mail was getting distributed to the correct region, and then the correct section, and then the correct city, and then the correct block in the city, and then finally on to the correct actual recipient. It's kind of a brilliant plan. It's very simple. It's very geographically sensible. You're dividing the country into regions that are not only geographically contiguous, but also sort of represent the degree to which people populate that area. So if you take a look at the map, you'll see zone 0 is pretty tiny. It's New England, basically, and maybe a little bit of New York and New Jersey, which is extremely densely populated area of the United States. That includes, New York City and Boston and all kinds of people live there. Take a look at zone 8. It covers the massive amount of Western United States, including where I live now in Idaho. Practically no people out here. One of the reasons I live here, and one of the reasons I moved from zone 0, because they had a whole lot of people. It kind of scales sensibly anyways, when you look at the map and you realize what the population distribution is. And it also left room for scaling correctly as populations grew and changed. Zone 7, when this came out in the 60s, Zone 7 didn't have as many people in it as it does today, but Zone 7 now includes Texas, and there's a lot of people living in Texas. So that had to scale, and it couldn't scale. Like, for instance, you couldn't take Zone 7 and split it into, Zone 7A or something like that, and Zone 7B. So someone had to think ahead enough to say, okay, well, how are we going to assign new zones within this and still stay consistent with the original plan? So I thought there was, I think there's a lot of interesting social engineering that went into the whole zip code plan. And part of what I like about Kristina's whole series is she's going into a lot of the engineering, the physical engineering of how mail is getting to you from wherever you are to wherever it's going. A lot of that has to do with automation. A lot of that has to do with actual physical robots that are sorting out mail based on OCR and barcodes and things like that. And all of that stuff is absolutely fascinating to me. Utterly fascinating, the organization and the engineered systems that go into moving something from one end of the country to the other.
Yeah, the scale of the problem is just kind of mind-boggling. And that's, I guess, what's kind of cool about the zip codes in a way is that, they break this gigantic problem down into a bunch of smaller chunks. Mm-hmm. I didn't know that the zip plus 4 scheme was over now, but apparently it was. This came in the mid 80s, and you could add an extra 4 digits to the number to give it, super precision. And I think our zip plus 4 actually identified the house that I grew up in Nashville. I think it was the +4 was actually equivalent to my house at that point in time. And apparently they don't use them anymore. Now the OCR on the whole address has gotten so accurate, and the lookup there has gotten so accurate that they just know exactly where you live anyway. And the +4s don't matter anymore. But I learned that by reading this article. Kristina hasn't gotten into the whole intelligent mail barcode thing and the various computer readable formats. And I wonder if she's going to do that in the next one.
Oh, for sure.
I'm going to have to stay tuned. If you haven't been following along in the You've Got Mail series, you should go back and check out some of the early ones and do yourself a favor and read them in chronological order, because this really is kind of a story of increasing technology being applied. And I think that's really fun too, to see how it evolved.
At all levels of the USPS, eventually someone's got to take that letter, look at it, and put it into a box or put it into a truck to put into a box. Someone knows the name and address. If you're getting something in the mail, someone has read that. Some physical, actual human has read it. And they will almost always make a good faith effort to get you your mail, no matter, whether the address is legible, if it or illegible, if it's been torn or damaged by water or something like that. If someone like Kristina's little picture here of a postcard from her collection where it just says Fred Minke, Somerset, Wisconsin.
Right.
I mean, that's an old postcard, but even now, if you did that, someone would make an attempt to get it to Fred Minke in Somerset, Wisconsin, without a zip code, without even a street address. They'll make an attempt to get it there. They may not get it correct. They may not be able to finish it, but they will make an attempt to get it there because somebody probably in the system knows Fred Minke, Somerset, Wisconsin, because they've seen mail go to this person before. That's another part of the whole mail system that's absolutely fascinating to me, is it's not just machines. It's people who, have a job that is not looked upon very highly. We all bitch about the, U.S. Postal Service and the fact that they don't want to work on Saturday and rain and sleet and snow. No, they won't do that anymore, blah, blah, blah. We all complain about it when we don't get our mail, but we don't really think about, actually it's a really tough job to figure out how to get all this stuff to everybody. And aside from the stories where you hear, someone has dumped out a sack of mail at the end of a cul-de-sac and gone on the way without delivering that stuff, pretty much everything that you put in the mail will get delivered one way or another, if it possibly can. And I think that's fascinating that we built a system that can do that.
And that wraps it up for this week's HACKADAY podcast. Thanks very much for listening. If you want to follow along with the links or leave some comments, head on over to hackaday.com/podcast. And as always, if you see anything cool or do anything cool, shoot us an email, tips@hackaday.com. And until next week,
keep on hacking.
All right.
There is literally no good news. Let me listen.
There.
Cool.
2 engineers. Oh, crap. Whose names I should know. That was very good.
What am I going to say about this one?
I will cut all of that out.
Well, thank you. Oh, can you hear those damn dogs?
This is one more episode, one more entry. This is another, what is it?
Installment?
Thank you.
Oh, wait a second. I've got the wrong one up here. All right. Did we beat that to death, you think?
I think we did.